Okay, so next up we're going to look at an arithmetic sequence. We're going to look at it a little more closely and how we come up with a formula for it. And when we write a formula for a sequence, in terms of only numbers and variable n, we call this the explicit formula. And the cool thing about the explicit formula is it's pretty powerful because you can plug in any number for n and it'll tell you that number term. So for example, if you're looking for the 10th term, you can plug in 10 for n and you get what is the 10th term. Unlike the recursive where you had to go one by one by one by one by one, this is a little more powerful. Now, what is the formula for an arithmetic sequence? A sub n, to find any term n in a sequence. You take the first term and you add n minus 1 times d, where d is the common difference, right? What you're adding or subtracting each time. Now, why does this work? Well, here's where it comes from. What it's saying is take the first term, and then you're going to add d how many times? Well, n minus 1 times. For example, if you want the 10th term, you have to add the common difference 9 times to the first term. So 10 minus 1, 9. You're going to add d 9 times. 10 minus 1, 9. Okay? So for example, let's look at a couple. Given the sequence, a sub n equals 5, 8, 11, 14. And hopefully you can see very quickly, common difference plus 3. Write an explicit formula for the sequence, then use your formula to find the 20th term in the sequence. So a couple of things here. What's the first term? What's the common difference? Well, the first term is 5. The common difference is 3. So we get to find any term, a sub n, it equals 5, the first term, plus n minus 1 times the common difference 3. So to find the 20th term, that's 5 plus 20 minus 1 times 3. So you have to take 5 and add 3 19 times to get the 20th term. That's going to be 5 plus, well, 19 times 3 is 57. So you get 62. Okay? Number 2. Given f of 9 equals negative 2, which function can be used to generate the sequence negative 8, negative 7.25, negative 6.5, negative 5.75? So hopefully you see something here. What's happening? Well, it's actually, be careful here, it's not subtracting, it's adding 0.75 each time. It's getting closer to 0, so it's adding. So if I wrote this, I'd get a sub n equals negative 8 plus n minus 1 times 0.75. Now, that kind of looks like choice 2, but that's a trap because it's subtraction. This is addition. That's no good. Well, now I don't really see what it is, but you can do a little bit of algebra here and you'll get it. Let's see. So this equals negative 8 plus 0.75n minus 0.75, and now hopefully you see we have like terms here. So this becomes negative 8.75 plus 0.75n, which is choice 3. So a little tricky. The other thing you could do here is you could plug in any number n and see if it matches the first, second, third, fourth term. Okay. Now, what if the question does not specify whether to write explicit or recursive? Then you get to choose, actually. You could do recursive, you could do explicit. Let's see. The first term in an arithmetic sequence is 6, and the fifth term is 34. Now, I kind of like to map these out when I get this, so I'll do something like this. 6, 2, 3, 4, 34. So what are we adding here? Well, let's see. The difference between 6 and 34, what is that? 34 minus 6 is 28. And how many terms have lapsed from the first to the fifth? That's 1, 2, 3, 4, right? 4 terms. So if you take the difference and divide it by the number of terms, 7 is what it goes up each time. It goes up 28 in 4 steps. That's 7 in 1 step. So that means this should be, let's make sure it works, 13, 20, 27, 34. And there you go. So now I know the first term is 6. The common difference is 7. So we get a sub n equals 6 plus n minus 1 times 7. This is the explicit formula. Good. Or if you want to write it recursive, you could have wrote recursive. Remember, you need the first term, and then you write a sub n equals a sub n minus 1 plus 7. Either one of these two answers would have worked. It's up to you. I kind of like the explicit. It's a lot more powerful. All right, number 4. In an arithmetic sequence, a sub 4 is 19, a sub 7 is 31. So again, this one I'm going to do here. Let's see, 19, then the 5th, the 6th, and the 7th is 31. Okay, so let's see. 31 minus 19 is 12, and it was in 4 steps. Nope, I lied, sorry. It was in 3 steps, so that means 4 in 1 step. So the common difference should be plus 4. So we get 23, 27, 31. Now, remember, we need the first term, so actually I'm going to go backwards as well. This is a sub 4, this was a sub 7, a sub 3, a sub 2, a sub 1. So this will be a sub 1, so we got to subtract 4. We get 15, 11, 7 is the initial value. Common difference is 4. And we get a sub n equals 7 plus n minus 1 times 4. Okay? Last one. Simon lost his library card and has an overdue library book. When the book was 5 days late, he owed $2.25, and when his book was 21 days late, he owed $6.25. Okay, so it says determine a formula for the nth term in the sequence. Well, let's see. So a sub 5 was 225, and a sub 21 all the way down here was 625. So it went up in 16 days. It went up how much? $4. So $4 in 16 days, that's 25 cents per day. Okay? So it went up 25 cents per day. Now we have to kind of work backwards and find out, well, what did he owe when it was 0 days late? That's a little interesting. There must be an initial fee of some sort. Let's see. Work backwards. We get a sub 1. Let's see. A sub 4 will be $2. A sub 3 will be $1.75. A sub 2 will be $1.50. A sub 1 will be $1.25. So the first day it's late, it's $1.25. So we get a sub n equals $1.25 plus n minus 1 times common difference, 0.25. And then the last part, determine how much he needs to pay if the book was 60 days late. So a sub 60 will equal $1.25 plus n minus 1 times 0.25, and instead of n, 60. So we're going to add 25 cents 50 times. So I'm just going to do this real quick in the calculator. $1.25 plus 60 minus 1, 59 times 0.25, and we get $16. He would owe $16.